Hello. This time I will be talking about not image processing or segmentation, but about microscopy. And more specifically, I will be talking about the Gatan 3-view system for serial block phase scanning electron microscopy. For last 14 years, or even more than 14 years, we've been using the system for volume EM. Soon it will be retired. And before that happens, I decided that I would like to make this kind of small tutorial on how we operate the system. Hopefully it will be useful for someone. Unfortunately, I won't have enough time. I have very limited time. And because of that, I most likely won't be able to show the most detailed aspects of system usage, but perhaps we'll cover rather basic aspects. So now we're in the room with the microscope. It is quite noisy here. I will explain a little bit on the parts when we turn off the system. But before that, let's dive into the computer because we need to start with some configuration settings.
This recording was done remotely, but naturally you're supposed to do all these operations in front of the computer. The screen which you see comes from Gatan 3-view computer, and the VNC viewer showing what we see on the microscope computer. The first task is login with using Gatan service account into the microscope computer. And on the microscope computer, we start XT microscope server. On this microscope server, we need to change motion node into the simulator by double-clicking on this green circle. Then we log out, and after that we log in with the Gatan 3-view account that we use for imaging. So we're now in the FEI microscope computer, and we start XT microscope server. We double check that the motion node is in the simulator mode, and then we can press the start button to start the server. The server is now started, and now we can log in into the user interface using the same Gatan 3-view account and the corresponding password. The window that we see on the screen offers us possibility to home the stage, but we won't do that because the stage is disconnected as it's in the simulator mode. So we press no, and then we close all the windows, and then we can press the vent button to vent the chamber. On the screen, actually, you see that it's already have 3-view system there, but in reality, you have your normal stage at this moment.
Now that when the pumps are off, we can take a look on the system. Here you can see the workstations. There are two workstations. On the right hand side there is a workstation for Quanta, and then on the left hand side there is a workstation for Gatan 3-view system. In the middle of the room there's a SEM FEI Quanta microscope with the standard door installed. On the left hand side from it you can see the chamber with Gatan 3-view system door in there, and the chamber is kept under vacuum. Behind the microscope we can see two pumps. On the left hand side there is the rotary pump, pre-pump number 1 for high vacuum, and on the right hand side there is the second pump for low vacuum mode. Then on the right hand side from them you can see the box with the power supply for the microscope, and then 3 boxes for the Gatan 3-view system. Let's go around them. On the top you can see the backscattered electron detector box, then in the middle the box which is called preview to control the microtome, And at the bottom there is the digiscan to control the beam. Also in this corner there is a table with the sample preparation stereo microscope that can be used to mount the sample. And also there is a gas bottle with nitrogen for venting the chamber. And there are a few cables that actually need to be removed. The first one cable here on the right hand side, which is the stage bias cable. What we need to do, we take away 2 screws on the side of it. So there's just standard connector, which could be untightened and removed. And then we put back the screws to make sure that they're not lost. Then we can put the cable away. The second thing here on the left hand side, you can see that there are cables that go from the door towards the microscope, and this cable needs to be removed. So we remove the grounding cable, and then we remove these two, one and the other one. Now the door is disconnected, but at the back it still have a safety screw here, and the screw needs to be taken away. So what I do, unscrew it completely. So now the door can be pulled out and taken away, and then replaced with the door from the 3D system. When we remove the door, the next thing is to mount the detector. So here is the detector, and depending on the type of detector, there could be different slots here, sockets. This one is from the newer version, and the older version has a serial connector for computers. And in our case, because we have the newer detector now, the connector here it's connected through this adapter. In order to connect the previous older detectors, this connector needs to be unscrewed. So there are just 2 screws there. Okay, and the detector is mounted here under the pole piece of the microscope. Let's mount it now. One needs to be very careful, because the problem that there are very fine wires here at the top that connects to the detector itself. So what we do, we take it the proper way, bring through at the corners here, like this, and then we bring it under the chamber here, under the pole piece, and then we slightly pull it over. And I usually do a little bit like slight tilt, anti-clockwise direction. And then we connect this cable into the proper socket here. So at the end, the system would look like this. So we have the detector, and then it gets connected to this socket on the right hand side. And then from here it goes to this preamp, which is this box here. And then after that it gets to the controllers through the wires at the back side. The next step is to put the Gatan preview door into the microscope chamber, and then put the standard microscope door into the chamber and pump it. On the 3D system, we keep the system under the vacuum, and the actual thing that we have here, it's like 2 valves. In order to release the vacuum, when the chamber, I undo this valve, and then the air comes through this way. Also, you can see that at the top, there is this, we use this kind of handle, like locking thing from mechanical shop to make sure that the door won't get loosened in case if the vacuum is lost. When you are changing the doors, make sure that you take the door using these handles on the sides, like this one, and the rail here, this one. So you can use these handles and the rail from this side and the same from the other side. So handle and the rail. Do not touch these ones or do not use these ones for holding the door, because these are like for the motors. You can break them quite easily. When closing the chamber door, make sure to do it very carefully and just check, because if you put the detector not properly or not really tight, then it may potentially hit the top part of the microtome. Now, when we close the door, we need to make sure that this locking screw is there. So we go to the back of the system and put this locking screw to make sure that when the door is open, it won't fall from the microscope. The next step is to pump the chamber. So already put this lock mechanism to make sure that the door won't fall apart. Optionally, it's possible to use the same similar screw and put it on this side to make sure that it won't sort of fall apart. But typically the screw is enough, or this lock mechanism is enough. Now I will close this valve and open this valve and then start the pump. And then I would press it a little bit from the side to make sure that the vacuum is actually forming inside the chamber. And we can keep it for a few minutes to make sure that the air is pumped away from the chamber. To finish pumping, I will close this valve and open this valve and then stop the pump. And then now we need to connect these cables. It's pretty straightforward. There are 7 cables and they're all labeled. Let's connect them now. So this cable for cut action, this cable for the stroke action. So this one is X. This one is AUX. This one is Z. This one is Y. And this one is SG. So now they're all connected. Now let's mount the sample. So the sample is, you can see it here. So this is the standard pin with the sample mounted on the top of it. I'm not sure, hopefully it can be seen. And the goal is to put it inside of this locker. So this locker has 3 eccentric cylinders that rotate, and then you can actually make sure that your sample, which you want to image, is in the center of the view. What we do first, we make sure that the screw at the bottom of this holder is undone and all the cylinders can be rotated. Then I rotated them so that they all on the same line, and these dots, which is on here, is all these 3 dots, they are on the one line. And then I can put my sample on the top of it, like this. The next step, I will go under the stereo microscope. I will rotate my sample so that its shape is kind of favorable. Maybe I'll be able to show it later, I don't know. And then I will tighten the screw. So now the screw will hold the pin inside of this assembly. And then I will use these wrenches to rotate the cylinders to make sure that I will bring the center of my block face of my block will align with the cross that I have in the microscope. So naturally the system needs to be calibrated beforehand, but usually it's quite straightforward, because what we do, we home the stage in the 3 view, and then we look where it is with the center of the pin, and then just move this adapter here at the bottom to bring the center of the pin into the center of the microscope. So the microscope itself sits here. I'll show you like this. So as it is, so we do not tighten it, because if you tighten it, it gets a little bit shifted. So the best is to keep it into this kind of minimum entropy state, as low as possible. So I switched on the light, and then I'll put the sample into here. Okay. Hopefully something is visible. So let me show you like differently. So it looks like this, and then I'll just basically make sure that the center of the block is properly aligned. So that's how the sample looked like when I put it in. Now I rotated the view and aligned the sample so that the center of it, approximately at the center of the cross. Sample aligned under the cross, we take it out from here, trying not to tilt these cylinders, and then they use the wrench drive, hex wrench to tighten the cylinders. And then if you want, you can put it back and then double check that it didn't shift it too much. So the sample is ready now for placing it into the 3 view. Now we take the sample and put it inside this holder in the 3 view. Make sure that it goes all the way to the bottom. Typically we'd like to keep the screw from one side always, because otherwise, if it will be like in the kind of in weird position, maybe like this, it can hit a little bit into assembly of the knife. So in our case, we usually keep this screw towards the door always, like this. Now we go to the other side of the system here, and let's take a look on the screws that we have. So first, you need to make sure that these 2 screws here, one on this side and one on the other side here, are both loosened. The screws are used to tighten the stage at a certain height. Then the next thing is that to make sure that the screw here, this big screw, is all the way loosened until the moment when it's actually at the same level as the assembly here. This screw lowers down the stage, or lifts it up, and the 2 screws on the side are locking the stage in one or the other position. So our goal again, just to make sure that we unscrew this one as much as possible until it reaches the level of the assembly. Next task is that the screw here, hopefully you can see it, like at this part, it's the screw that locks our holder with the sample in this assembly. What we need to do, we need to tighten this, but before doing that, we'll put the stereo microscope on the door to make sure that it's in the correct position. While we have it open, let's take a look a little bit on a few other things. This is the knife, And the two screws here are used to hold the knife. The idea is that by losing these screws, you can move the knife left and right and put it aligned to your sample as much as needed. To tighten this, you press from the top over the knife and gently tighten this screw and after that the other screw, so that the knife assembly is staying in place. Also, there is one more screw here, which is at the bottom. Hopefully you can see this. So this screw changes position of the knife forward to us or backwards from us. And that it can be used to tweak what's the area the knife will cut. And to fix this, we need to undo this screw, this nut, the big nut here. So we undo it, and then after that we can move this, rotate this screw in order to move knife towards us or away from us. When we find the correct position, we take this away, and then we tighten this nut to make sure that it's locked. So let's now put the stereo microscope on the door. And to do that, we have this bracket here, so like this. And then what we do, we put it here on the door, like this. You can see that I just put it here when it sits, and then I tighten this screw here. Right. And then after that, I can take the same stereo microscope that we used to align the sample on the holder and put it over that thing which I put on the door, like this. And then this time you really need to tighten this black screw to make sure that it sits properly attached. So let's take a look. So here we have this holder for the stereo microscope on the door, and then we have the stereo microscope that is facing over the sample. What you may need to do, you may need to little bit tilt it a little bit so that it actually looking on the top of the sample block. The next thing here on the door, there is the LED that will be used to put the light over the sample. Now it's off because we have not switched the boxes yet for the 3-view. So we connected the cables. Now we go to the boxes here, and then we switch them on. And the third box has the switch on the front side here. Now it's done, and then we can go back to the microscope computer, actually the Gatan 3D computer, and start a digital micrograph.
Now we're in Gatan 3-view workstation, and here from the desktop we start GMS3. GMS3 is now starting, and then we wait until it, most likely it will show a dialog that tells us that it can't connect to a server. In this case, we just need to press a few times retry button. And after a few of these clicks, it typically connects to server normally. After startup, we go to the techniques manager and select 3-view acquisition. And this opens up panels on the right-hand side of the screen.
Now we switched all the boxes for 3-view and also started that on micrograph. And then now if we put this LED, it will lighten. Now use this bracket to keep the stereo microscope can be adjusted if needed. This lower one tightens it so it sits firmly on the door, and this one can be used to lift it up and down. To start with, we need to make sure that our diamond knife is above the sample. And to do that, we can do the following operation. I can take a hex wrench, place it into here, and then I can go to the computer and then press microton. When we press the microton button, the lever which keeps the knife moves, but the knife is not moving because it's fixed with this hex wrench there. Let me show you how it looks from the other side. Yeah, it's quite difficult to see in a way. But the idea is that we just make sure that the knife doesn't go unless we really see how it goes. Now we'll look again from this position. And my goal is now just hold the leather, remove the wrench, and then look by eyes from here to see whether the knife goes over my sample. It's possible to do as well using the stereo microscope and focusing on the edge of the knife, but I found it easy and quicker for me to do it this way because I sort of know the heights of the samples. Now we'll sit behind the stereo microscope and we make sure that we can see the sample. We can change the magnification and then focus. Yeah, it's probably badly seen, but that's how it looks. You see the edge of the knife and the sample under. Now we will rotate the sample so that the front face is perpendicular to the knife. And then after that we tighten it with the screw. And now I tighten the sample in the holder by rotating the screw, which is just above the big screw for the screwdriver. Now we need to make sure that our our stage is in the stroke up position.
Go to the knife settings in the GMS3 and then uncheck oscillator, and you can also make the speed of the knife a bit faster to 0.4 millimeters per second, and then press the stroke up.
And now we can lift the stage using the screw and the screwdriver up by monitoring the distance between the knife edge and the block face. The best way of doing this is basically you move this lever to bring the knife over the sample, and after that you're starting to rotate the screw to lift up the sample closer to the knife edge. This is the trickiest part in the way to find out what would be the actual distance, to estimate the distance between the knife edge and the top of the block face, because the top of the block face may be slightly tilted and things like that. The easiest one is to have to make sure that the sample is coated, because when it's coated it really reflects the light pretty well. And also you can play around with this LED by moving it into the different directions to make sure that the shadow or this kind of band of light under the knife is properly visible. To move knife left or right, we undo these two screws here, these two. After that we can move this knife assembly left or right, and then after that we can press it from the top, kind of like this, while with the other hand you can tighten this screw first, the one on the left hand side, after that follow it with the one on the right hand side. Since we're now talking about position, let's take a look about three positions that the knife can have. The first position is called imaging. In this position the knife is retracted all the way and the whole sample is available for SEM beam to interact with. The second position is called microton. In this position the knife moves over the sample and it's ready to do a cut. Now I press cut. and the knife will slowly do the cut of 1.2 millimeters. Then we can press again microtome to return it back into the microtome position, which is just before it is doing the cut. When we got close, as much closer as possible using the screwdriver, now we need to check that the knife travels all the way through the block face. We need to make sure that the knife edge is before the block. When we do the cut, it covers all the way through the block, and then when it tracks back, it's still the path of the knife is larger than the block face. In the software, we put cut thickness to be something small, let's say 5 nanometers, and then we can do, for example, 4 cuts. We can press the stroke down, and then we press the start button. While doing these cuts, we can go back to the microscope, to the stereo microscope, and just check whether the knife covers the whole block face from the beginning of it to its full length. This is super important, otherwise you may damage the knife if the knife doesn't cover the whole block face. Now it's fine and we can stop it. If it's not fine, then you need to adjust a little bit the knife position using the screws that I showed before. Now we can lock this stage in this position. We tighten these 2 screws on the sides of the knife. So one of them is this, and the other one, the similar screw on the other side. So now we can double check the things. So we have our screw which locks the sample holder is tightened. The 2 other screws that lock the stage are also tightened.
Before going further, let's take a look on the principle how knife is traveling in the system. I made this scheme quite a long time ago, but here in the first image we can see the block, our pin with the sample and the knife. This is knife in the sort of position before the cut. So actually for imaging it will be even retracted even further. So first thing, the specimen is pulled up by a certain distance, which is our cutting step. Let's say if we want to cut the block with the 50 nanometers, that's the block is lifted up by 50 nanometers. That the knife cuts the block face, and then the section which is formed is typically stick on the top of the knife. After that, the knife, if we would just retract it as it is, then it can be damaged by the block. In order to make sure that the knife is not damaged by the block, we need to, the system moves the block down by probably 10 micrometers. And this step is called stroke down and stroke up. In the stroke up step, it is up there. And when it's unchecked, stroke down, it is moved about 10 micrometers down, allowing us to retract the knife without any potential damage to the knife. So after knife is retracted, the area is available for imaging.
Now we're ready to start the approach. First we did the mechanical approaches with the screwdriver, but now it's too close to continue it manually. What we'll do approach in the 3 view, monitoring the block face, waiting for the moment when the knife will start actually cutting the sections from the block face. To do that, we define the thickness. The thickness could be any number between 0 and 200, but it can't be more than 200. Then we define number of cuts, let's say 50 cuts. You can remember you can always stop it at any moment. And then here in the settings, we can specify the knife cutting speed, retraction speed, and whether or not we want to use oscillator. Typically, in approach mode, I cut at 0.4 millimeters per second, and then my retraction speed is 1.2.
And in the approach mode, well, it's better to use oscillator because it's better for knife, but because the door is open, this ultrasound is a bit annoying. You can disconnect the cable, or I typically just uncheck this checkbox. So now it will start approach, but it won't use the oscillator at this moment. When I close the chamber, I will switch the oscillator on. We can press start. But you can see here, this knife goes to microton position, then it makes a cut, then it retracts, lifts up the stage by these 200 nanometers, and continue doing this operation.
So we're now in the approach mode. The knife cuts automatically with 200 nanometers per iteration. And while doing this, we monitor the progress by looking through the stereo microscope to find out the moment when we start cutting. Now the sections are piling up on the knife in the approach mode.
When you start seeing that the samples are already cut, you can stop this approach mode at any moment by pressing the stop button here. If, for example, after these 50 runs you haven't reached the state when it cuts, you can increase this, or you can change this value to something other value, or just keep 50 and press the start button again.
We stop the approach now. There are some sections on the knife and it's better to remove them. And I typically use the compressed air flux to little bit gently blow them away from the knife edge. Other additional procedures could be done to remove extra sections that cannot be removed using this blower. But usually this is enough for me for most of the cases. But it's possible to use a brush, or maybe to use some styrofoam, some kind of this material. We take away now the stereo microscope, put it back to that stand that we have on our preparation table. Take away this bracket. Double check that all the screws are tightened. So remember that we have at least 3 screws to check. The one screw which holds the sample, the 2 screws that hold the stage. If one of the screws is not tightened all the way, then the cutting may not be super stable. And finally, we can close the door. So just pull the door over all the way into the chamber. Now it's done, and now we can press the pump button on the microscope controller.
The door is locked now, and then we can pump the chamber. I go back to the main microscope computer. Let's see, I can press F6 to update the view. We can see our detector, the knife, the sample. And now we can press the pump button to start pumping until the chamber is pumped and this lower icon turns from the orange and gray colors into the green color.
For the low vacuum mode, you would need to have a water. And the water bottle is located here in this container. The idea is that it is warmed up, and then all these water vapors, whenever is needed, injected into the microscope chamber. It's important to keep the water level not too much, not too low, otherwise it won't be able to keep the pressure precisely. So we have some marks there that could be used. But in general, this is kind of decent level. and then it's whenever it's needed, it needs to be refilled.
We're looking at the XT microscope controller for the microscope, and here we can select the vacuum mode. Now it's in the high vacuum mode, but we can also choose low vacuum mode, which is standard for 3-view acquisition, or ESEM. In the chamber pressure, you can pick any pressure you want, but typical range is about 0.2, 0.3, or maybe 0.1 millibar. Sometimes we can go to 0.4. In the spot size, you can select how wide is the beam, what's the current to be used, but typically work at 3, and the typical voltage that is for us is 2.5. So when the pressure is achieved, it's green, and we can turn on the beam. Now I'll put it down, and then we will see in the GMS3 what we can see on the block. Start the beam by pressing the view button, and here the image, and it looks blurred because what we need to do, we need to use the knobs on the controller to bring the sample into the focus. Now it looks better, but we need to do the fine focus, and for this I use the search mode, which I defined as the very small area which is scanned with the 15 microsecond dwell time. I press again the view button to start imaging. It fits it to the screen, but I have this different small set of tools that I set it to 1 per 1. So 1 pixel on the screen matches 1 pixel of the image. And then I zoom in towards the data set, and I use my focus and stigmators to bring the sample sharp, to make the image sharp. If I want to move, I can right click and then use this stage navigation tool to recenter it to the area which I can use for focusing. So let's zoom in somewhere, and then let's use that area for focusing. It's good to do the focusing as quick as possible because the beam can damage the sample and gets a little bit kind of burned. It changes its position, so it makes like a small sort of hole trench. And the quicker you do the focusing, the better typically results.
Let's talk now about widgets of this user interface. Unfortunately, I am not in front of the microscope, but in my office, because my this screen capturing program, I only have it here. That's why I do not have access to these mechanical controls for zooming in, zooming out, focusing, and things like that. So I will be a little bit limited with my possibilities of doing quite quick operations. Let's first quickly go to press the preview and then press view to update the to make an overview of what we have. I can't zooming in, zooming out, but I can do it through these widgets here. I can put the magnification, let's say 1, and then apply settings. Maybe let's put 0.5. So it's not super convenient. It's possible to use, but it's slightly not practical. I can also do this, change this through the VLC viewer here. I can go and change the parameters, such as, for example, magnification, depending what's like easier for you. Not naturally, you sitting in front of the microscope and things way easier. Let's do it like 0.1. Now with magnification of 100 times, you can see here this white rim here. This is aperture. This is aperture of the detector, and this is our block face. Let's make it maybe 35 or something like that. Just wanted to show the full block, but without really looking that much at the edges of my detector. Okay. So let's now talk a little bit on these different widgets. First, here you can see there is a microscope panel, and on this panel you can see the current state. There is a beam that it gets illuminated, and that it's not blanked. It hits the sample. We can press the blank button, and then the beam gets blanked. There will be no signal.
and I can press blank again, and then this beam gets unblanked. Then here you can have different detectors, and then if you right click over this detector, you can get the detector settings. And in terms of this backscatter detector, it's very important because depending on the imaging conditions, you may need to adjust these values. I will probably talk a little bit later about this, how we do that, but rather let's go down the line to see more options that we have here. We can get the calibration, well, not the calibrate, but they see that the things are calibrated, such as pixel size. Then there is SEM imaging, so these are the parameters of our microscope. You can see the parameter of the focus, so we are at 5.6 millimeters, parameter for X and Y stigmator for the beam. When we can do automatic focusing here directly, but in many cases it's wise to make the notes of these values. For example, I can open notes here and then put this in my focus. This would be my stigmator X, and this would be my stigmator Y. In case if this autofocus procedure will mess up the parameter, so I can always like remotely put back these numbers, and then the focus and stigmator values will be restored. SEM stage. Okay, actually let's do it like this. So it's possible to go to any position. So you can see now that we're at X, Y coordinates like this, and this is our Z coordinate, which is actually, I'm not quite sure what it is, honestly. Maybe, yeah, I never used this. Because to move the stage, we typically just use the controller just to move the stage, to recenter it. But what's more interesting is the stage tracker. What we can do, we can define any position. For example, now we're in the middle of our block, and I can press plus here, and I put, let's say, center of the block. Now I can go to any other position, and then, for example, you may have multiple ROIs that you want to image. And then after that, I can, let's say, we can go to the middle of this dark area, and when it stops moving, we can press plus and say this is our ROI 1. And then any moment we can just select the position, double click on this position, and then the stage will be moved to that position. Or you can press the go to button. There are some settings, and the settings basically allow you to define which of the parameters you want to tweak. Typically you just want to go, of course, X, Y, do not go to these two. In addition, there is a second tab here which is called display, and in display what you can see, you see the histogram of the current signal, and then it's automatically calculated. But if your contrast is not good for you for some reasons, you can actually hold the left mouse button and select an area. In this case, the contrast will be stretched to these values, and then it won't be auto surveyed. To reset it, you can just double click on this color bar here, or perhaps just press this auto survey button. Let's test this. Yes. This brightness, contrast, and then gamma I do not touch because I don't really see any point of this. Instead, what we do, we tweak the detector settings within here. Controls, well, nothing here for some reason. Slice, nothing for slice, and imaging 4, we can see the pixel size and the voltage magnification. These are basically used if we want to look the stack. I do not really do it in this program, but if you want, it's possible. All right. Next, let's go to the right-hand side. Here we're in the 3-view acquisition, which we opened by selecting the 3-view checkbox, or like 3-view box or 3-view button within this techniques dialog, which is available when you start the program. The first tab here is called, or the first panel here is called scan. Here we can have different options. Let me just pause this. There are two modes, the scan and preview. And you can see selecting any of this mode, you modify the pixels time. It means that in the search mode, the pixel time will be 15 microsecond. In the preview mode, it will be 4 microsecond. You can change it. And then you selected the mode, and then when you press the view button, this mode will be used for scanning. Now we're in the preview mode. Then I press the view button to stop it. You see it's now turned from blue to gray. Now I can change the mode to search, press view again, and now it will scan it in the view mode with the pixel size of 15 microsecond in this particular case. Now what we can do, we can click on the setup button here, and this brings us the dialog which allows us to specify the exact parameters of each of these modes. There's the search mode, the preview mode, and there's the capture mode. The search mode is 124 by 256. Again, you can put whatever you want. And the 15 microsecond. I use this mode for focusing. So not really search, but rather just the focusing. And you can also tweak some other parameters. The preview mode, it's in my case, it's the square, 600 by 600 pixels with the pixel dwell time 4 microsecond per pixel. And finally, there is a capture mode. Let's put, for example, 248 by 248, 8 microsecond. Here under, you can say how long it takes to get one frame. And naturally, with this mode, with the half-second update of the frame, it's quite easy to focus. This is a bit slower, and this is, of course, just for the snapshots. Also, what we can do here at the bottom part, we can select the detectors that we want to use. Now you can see that each of these modes will give us access to the backscatter detector, which we installed under the pole piece. Also, you can turn on the SEM detector. For example, let's see, I make only the SEM detector visible in the preview mode by clicking these checkboxes. Let's press OK. Let's go to the preview mode here and press the view button. Okay. It may complain about something, but hopefully it will work. Yes. So here you can see the backscatter detector, and here you can see the secondary electron detector, which is coming directly from Quanta. And if I would go to Quanta view, so I go to this mode, then here I can select the detector secondary electrons, and then if I press F6 to update, you would see that it gives me the secondary electron detector image. In this mode, we need to have the first quadrant to work properly in the external mode. In this case, the Gatan 3 view will be able to show us the images. Let's just start again. So we have now collecting two detectors, and if I move somewhere, let's say here, you see that both detectors are updated at the same time. So in that sense, it's possible to do imaging of two detectors. Within these display tools, there is the button which is with this cross that I made to make sure that it identifies the center of the image, because if I need to move the image slightly, it's a little bit easier to have the cross in the center. So I stop the view. Now I'll go back to the settings. Okay, just get back here, and then avalanche. And then you can also define like whether you want to 16-bit or 8-bit imaging in each of these modes. When we work, we typically collect the backscattered images with 16-bit, which means the 2 bytes. In the advanced mode, from important things here, you can do some modifications, but I think the default settings or not the settings that we have here, they're pretty okay. And again, it would require a little bit more deeper dive into which of these parameters, what they do. Then if we want to do capture, and again the settings for capture we defined in this window, let me close this and this. I press the capture button, and now the microscope will collect an image of my field of view with the settings that I specified in the settings mode in the settings under the capture mode. So now we collect 2K by 2K with the pixel size. Well, actually, I'm not sure what's the pixel size there because you can't define it here. You just define number of pixels with 2K by 2K pixels. When I press 1-to-1 button here in display tools, I will zoom in to see my image in the full magnification, or I can use these buttons in order to zoom out of this. When the image is collected, it will be automatically sent to this tab which is called STEM for some reason. You can actually double click on this and rename it to any image, or let's put it just images. Then, for example, let's say I change magnification from here. Sorry, SEM imaging. Let's put 1K, and now capture another image. And this new collected image will go also to this images tab. Basically, the idea, all images that are collected will be assembled under images tab, or it's called by default stat. Let's just wait for it. So the image is captured. Oh, well, you see actually what happens, it's always put it into STEM. And then if I rename the folder, they won't go automatically there. But what I can do, I can right click on the image and move it to any workspace I wish. For example, we can move this one also to these images. Perhaps we want to keep these images and do not delete them in the workspace. Now there is a shortcut which is called Ctrl-L. If you press this, it arranges all the images in the current workspace so that you see them as you know, that they occupy most of the space. And then if you want to save it, just press Ctrl-S. Let's make a folder for ourselves. Let's go to D drive, users, test user, sample 1. Let's put here, this is 01 overview. Let's put it block overview. And this, for example, could be Ctrl-S, block overview, zoom, let's put it 02. So I save them, and now I can basically close these files. Let's go to the preview mode. Oh, I probably unchecked the secondary electrons. Let's go back to the settings. Yes. Press OK. And I will go back to my magnification, which was 55 or something like this. We can rotate the view. So if you press the rotate button here, you can actually rotate the view by providing the angle. And this is useful sometimes because if your structure is a little bit like tilted, because when we do ROI imaging, the ROIs that we place, they are rectangular. So you may want to rotate your image, and you can do it using this option. The problem, however, that sometimes with multi-ROIs, it may not really work super precisely. There is some bug sometimes triggered that could, so it can lose this rotation value. So just test before you actually do it for real. There's also like a focus mode, but yeah, I usually just use search for the focusing. Maybe let's test it if I go to the preview now and then I press the focus. What it does, it opens the small window which you can move around, you can change its size, and then you can do the focusing. But now to me it's quite fast, so I'm not quite sure how I can easily change these parameters for focusing. In my case, I usually try to use this the search mode to focus the things. So here, just make sure that you waited until the operation which you're doing now is over. For example, do not really press any other buttons unless you, for example, stop the view. So I stopped the view, made sure that it's actually finished, and the button changed its color, and I can go and press capture, or maybe go somewhere, do something else. Otherwise, it may actually crash. So that happens sometimes if you do things too quickly. Let's now talk about the second panel on the right hand side, which is sample approach. We're using this panel during the approach when we were trying to start cutting the block face in the automatic mode. But let's now dive deeper what kind of options we have in this panel. First, there are the three modes. The first is the imaging mode, which is suitable for capturing. The microtome mode when the knife is ready for the cut. And then the cut when it actually made the cutting stroke. Now in the microtome mode, we can press the view button again. Actually, we won't see anything now because we are at quite low magnification. Let's pause the view by pressing again this button, and I change the magnification to be 0.80, and then press the view button again. Now we zoom out quite heavily, we see the aperture, and here at the bottom we see the knife. So this is the position of the knife in the microtome state. This is as further knife as it can go. I can stop the view now, and then, for example, I can change the knife to, for example, to move it by 400 micrometers. When it finishes the movement, I can press again the view button, and I can see the position of the knife over the block face. You see it's here. Finally, I can press cut, and then it will move the knife all the way up to here. And I can potentially have a chance of evaluating how much area the knife cuts. Let's see where it's going to be here, the edge of my block face. Yeah, so you see it cuts all the way through the block. Let's press imaging. We can see the knife position. If now I press the start button, what it will do, it will start the approach mode with the parameters that we can define using this knife parameters dialog. It will use 0.4 millimeters per second the cutting speed, 1.2 millimeters retraction speed, and now we can actually turn on the oscillator. When I press start, the knife will be making the cuts with the step 200 nanometers, and it will use these parameters that I specified here. And while knife cuts, you can see its position in this dialog, and then in total you have this progress bar. So out of this number of cuts that we specified, 50, we cut now 2, and now 3 cuts. Let's stop it. For the approach, we can specify a number of cuts. And the final, it's the stage Z. The stage Z is the coordinates of the Z in the micrometers. If I press home Z, it will go to 0. Usually, when we're finishing a run, we move we home the stage, so it goes to 0, and after that we lift it up by 10 micrometers. So to remove all possible backlashes and things like that. And it's important when we do approach, especially manually, make sure that the stroke up is checked, because otherwise you can really bring it closer. Let me show again this nice scheme that I showed. For example, you approached using the screwdriver mechanical approach. You did so well that it can potentially do cuts right away. But if you did it without the stroke up, it means that on the first cut you can already remove not 200 nanometers, but even like few micrometers at once. So be very careful with that during the approach. And finally, as the warning, I showed that you can move the knife and you can actually see its position using the SEM beam, but I would not really recommend to use it frequently. Because I think in that mode you can easily crash the program if knife is moving and you're starting the beam at the same time. There are lots of kind of Let's close this one. Maybe close this image. Let's now go to the setup imaging location. In general, there are 3 modes that you can use. One of them called in place. Basically the idea that whatever you see, that's what you get, and then you can specify the image size for that mode, pixel time, pixel size, and the rotation if you wish. Well, it sounds quite straightforward and simple, but I do not really use it. In fact, out of the three modes, I only use the multi-ROI mode. There's a montage mode when you can specify the size of each area. You can specify the dimensions. For example, you can do 2 by 2, let's say 3 by 3 stitching, or maybe 2 by 1. And you can specify the overlap, and then there are additional parameters to save each of these ROIs as a folder. So it's pretty useful. We just don't use it that much ourselves, because after that you need to deal a little bit with the stitching, and then it's potentially could be quite tricky. Instead, we use this multi-ROI mode, and I will explain how it works. It's super easy and super nice to use. For example, let's assume that this is our block face, and then we want to image something somewhere. What we do, I will collect first the overview of my block face. I will change magnification to 135 times preview. Yeah, that's my block face. Now what I do, I go to, I take a capture. I just make it a little bit quicker. Let's take 1K by 1K. I do a capture of the block face, or maybe zoomed into some area that I want to image, if I want to be very precise with whatever area I want to select. Let's see, now this is block face. This is, by the way, is the intestine, mouse intestine. There are crypts here, and this is the center of this intestine tube. I create a new workspace that I can name, let's say, run 01. And now I can move this image into that workspace. So now I have this image here, and in this panel, setup image location, I press the survey button. What it does, it takes this image and assigns this as a survey. The survey is like a map. You can actually, after that you can specify any locations on this map, and then that location will be collected. Let's see how it works. For example, let's assume that we want to take a couple of crypts here. I need to specify important parameters. Let's say we want to specify what would be the image size. Okay, now I have 7K. Let's put 248 by 248, like a square box. We specify what would be the pixel time. Now in a high vac, let's put like 4 microsecond. And then specify what would be the pixel size. And now if I press add ROI, it creates the ROI with these parameters. Now what I can do, I can move the size of this ROI, and you see it's the size is properly respected here. Then I can move it, and that would be, for example, my first area. Let's put it here. Just to make it quick, I'll just put like 1 microsecond, because we're not starting yet the run, just kind of quickly show you the idea. Then, for example, let's say you want to have another one. You press add ROI again, and with another ROI. For example, you want to take another crypt here, and maybe you want to have it like bigger, like this. Finally, maybe you want to take an overview. What you can do in this case, let's say my overview, I don't want to have that high resolution. Maybe I want to have it with 50 nanometers pixel size. I add another ROI. Now you see it's bigger, and I can specify certain area like that. Or maybe I want to take it with the 150, and okay, well, I can't do it 150 because it's over my area, but maybe let's put it 100, and maybe I can take the overview of the whole area of my crypt like this, maybe even like that. No, let's just do it like this. And what I can do as well, I can specify whether I want to do this, collect this ROI every section, or maybe each 20th section. Because this is my overview, I probably don't want to have it each section, so I can say, okay, please do it each 20th section. Now, the typical problem with this, you see, I can't really see, if I want to modify these boxes, I can't do it because my ROI box is over them. Usually, what you do in this case, you can put it to back, send it to back. Now I'll have access to these two. And for example, I can change the settings for this. For example, let's take this one with 25 nanometers and make it smaller, while the other one, we can keep it like this. This one will be taken each 20 section, but let's for now, for the test, I just put like 4, and then these 2 with the other settings. And then finally, in order to start the run, we just go to the last panel at the bottom here, which is called data acquisition. We define the parameters such as cut thickness. Well, with this review system, you can technically go from 30 nanometers and above. We usually can cut at 30, 40, or 50. These are our typical values, but of course it depends on particular target. Let's put now, to make it easier, 50. The larger the value, easier it sort of make it to work. Then in this settings button, you can specify the cutting speed. Well, actually, I can see here it's quite high speed. It should be typically we cut at 0.1, and with oscillator and the retraction speed is this 1.2. These settings are different. So the settings at the approach mode are different from the settings in the imaging mode. But the idea is that just try to make it as slow as possible. 0.1 is a really good number. Then we define number of cuts, 250 cuts or maybe 350 cuts, where we want to put it. Test user, so I'll make a new run 01A, and then I name it here 01A. So that would be run 1A. Then cut alert. This is a nice feature. If the system will find out that there are problems, it will actually stop the run. It's capable of detecting problems when if the beam gets messed up or the pressure gets messed up, or you have like a big section on the top of this that blocks the view. You can define sending status reports. Well, usually you need to, there's a way you can do that. It sends this downsampled snapshot, but you need to specify this SMTP server, and you can use this SMTP relay from Breva.com. You just create an account there, it gives you the password, and you can just send it. But yeah, change it to your email. Then we can turn off voltage when the run is finished. So if this is if this checkbox is checked, then when the run is over, it's automatically switch off the voltage. And finally, you can do the check focus, and in this case you can specify, for example, every 12 hours you will do the check. It will do the check focus with the pixel size 8 in the center of your image. If you press this one, you should be careful with this. If you have a tissue, then it works pretty well, like a brain, for example. But if it's more like something with lots of empty space, it may not really give you the good focus. And when we're ready, we can press capture. Let me just quickly check so we can quickly do the like 10 cuts or something. So on the right click, you can specify different options. Like we already checked the move to workspace. You can actually move the image to any workspace, or you can duplicate it to the other workspace. You can do some things like doing Fourier transform on fly. I hope. Let's test it. If I press FFT, so you can see there's Fourier, and you can potentially use it for focusing. Sort of what you need to do, you need to make sure that your signal becomes as broad as possible. But I probably have to focus a bit, or actually not focus, but zoom in a little bit more, because otherwise now it sees this these lines, edges of our sample. Then you can have a bit of on the layout things. You can save it directly from here. Then you can get to this image info, and the image info is useful because in the calibration section you can actually see what's the pixel size of your data, and there are also some other parameters like microscope details, and there are lots of tags here with the all kind of metadata. For example, what was the dwell time, and then coordinates and things like that. And all that is saved with the data if you save it in this digital micrograph 4 format. Here at the top, there are other things. I do not remember actually all of them. I can tell you which ones I used. I used this one with the cross. This allows us to navigate around, so I can click at any at any place within the block, and then this stage will be moved so that the point is in the center of the view. Then this one is just a standard picking tool. I can select this arrow, the scale bar, and press delete button to remove it. This is the pen or drag. It's basically if you have image collected, then you can pan around. So actually, let's stop the view. Let's get back to our folder. So we have these snapshots. I can put them here. And then if I have this hand, I can use the scroll wheel to zoom, and then I can pan around by pressing the left mouse button. This was something useful, but I don't remember what was that. And then I can put annotations and the boxes. Perhaps the most interesting part through this is actually when we are in this preview mode. What you can do, you can turn on this wave monitor. The wave monitor shows you intensity, so it basically, while it scans, it shows you intensity of the signal. So the bottom line here, it's the black, so you see when it's down there, it means that this scanning line goes over this dark area. That actually makes the scan slower. Let's put it like 16 to see it better, and then press the view. So you see it scans slower now, and when it gets to this dark area of the platinum coated block face, this intensity of the signal is low. This is black, and the upper part here is the whites. Now if I go back to this detector settings, for example, I increase my brightness to be 1.5, so you see it gets saturated here, and then this line may go over this edge. For example, let's put 2.5. So you see it kind of changes this. Maybe it's inverted because the signal is inverted. Maybe it goes a little bit like a different way I was anticipating. But basically, what you can do, you can use this line and use these backscatter detectors, which are available from this menu. Right-click over BSE, sort of that you can tweak the parameters. Then I go back here and put back to my 4. Start the view. Here, this is the top of the block face. This part, which you see here, this is exposed area, so we see tissue. And this dark part here, it's the area which is not yet exposed. This dark signal here comes from the platinum that we have on the top of our sample to make it conductive, and it also helps with the bringing knife, with the approach. But then what you can do, you can use the high voltage in order to see through this layer. I can change the voltage to say 7.5 kilovolts, apply settings. Now I don't see anything. And then in this case, what I need to do, I need to tweak a little bit these parameters to make sure that I can actually see through the things. And then with the high voltage, I can potentially see a certain depth under this platinum coat. And here you can see that this part of the tissue is not yet exposed. But then I can actually see that that's my that the edge of this intestine tissue is actually following, this wheel is following that line. Then I can go to that place. I can increase my magnification, let's say 2K. And then I can potentially see the cells even there. But in order to see this, we really need to modify this contrast and brightness settings. So let's get back to 2.5 kV. Now I go back to this run 1 and let's see what happens. We specified the thickness, we specified number of cuts, we basically specify everything, and then let's press capture. What it says that it will now show us each of this area that we picked, so we can actually have a chance to fine-tune these ROIs. Press OK, so that will be 0 overview image. So the stage moved to the center. Oh, it's not overview, it's actually this one. So it's pretty good, but you see it's a little bit shifted because I took my this this area when in this kind of for the big overview. If I would have zoomed in a bit closer, tighter to that area, I could have placed this a bit more specific, more precisely. So I press cancel here, and then I can move this a little bit towards like this, and then I press capture again. It will give me updated overview depending how I moved my ROI. Well, okay, maybe it's fine. I say okay. Then it goes to the next one. Then if it's okay, then I can just press OK. If it's not okay, then I can, okay, well, it's also a little bit shifted. I press cancel here. Close these two windows because I don't need them. Maybe move this one a little bit to here. Maybe this one a little bit also like that. Press capture. Unfortunately, there is no like instant or interactive update of the view if you start moving the things by yourself. So you really have to stop this or cancel this preview, move the ROIs, and then only after that sort of restart it again. Which, for example, if I would have 3 ROIs, it would take a bit more time than if I would be able to do it like interactively. Yeah, this looks good. Press OK. And then because it can't show you, it will show like mini stack of some number of sections, and it asks for which of this ROI I want to have it. Oh, well, let's put number 1. And they're starting from 0. So 0, 1, and 2. Now it starts the run. Here would be the 3 images, the 3 ROI 1, 0, ROI 1, and ROI 2 for the overview. And one of these will also be shown as this mini stack with the sections that we can monitor. Now, well, actually I put the speed because I wanted just to quickly show how the things are not really doing the real run, because for real run we have to do a few other things that I wanted to show, because you see we're not focused and most likely it won't start imaging right away. This is the first ROI, it collects it, then go to the second ROI, collects it, and then go to the overview, and after that it will make a cut and repeat the process. But it will only do imaging of the ROI 2 every 4 cuts, because that's what our parameters that we specified here. Yeah, you can see the images are quite bad, but I'm just like, I know that it won't basically do anything. And anyway, for the actual demo, like now I will show for one single ROI to make it quicker. What you can see here, this is the stack, and now it will you can use the arrows in order to see the changes between the sections, but and then it will show the one the ROI that we specified when we started the run, and this is our overview. Each of these files go to its own subfolder. So this is the run 01A is the one that I specified, and here there are 3 subfolders. This folder for ROI 0, ROI 1, and ROI 2. And the survey image is the image which has these ROI boxes that we specified, this one. What you can do, you can later just drag and drop this image into the digital micrograph, and then after that you can actually reutilize these ROIs. For example, if you want to continue a run using the same parameters. Let's see what happens here. Yeah, now it made a cut, and now it's doing imaging again, but most likely it won't do anything. So the problem is that there's most likely there's a bit of air bubbles in the plastic, and then when you put it into vacuum, the block shrinks. And in order to start actually cutting, we need to either expose the area a little bit, like bake it sort of, or keep it for a while under the vacuum. And that what happened now is that because the sample was not in the vacuum, we started to cut, then it shrank a little bit, so our plane of the block face now is a bit below the knife. If I will keep on imaging, it will actually catch up, but I don't want to wait. Basically, I want to make sure that I will start cutting right away. So now here I can use left and right mouse button to see the changes. Well, first of all, what we can see here, we see this area of charging. This is the dark hollow here. The charging is the problem, is the effect when we can't, the electrons that hit the sample, they can't escape. And if they can't escape, they generate this excessive cloud of negative charge, which generates more electrons that should come from that area. And on this V system, it's possible to compensate using the low vacuum mode. And that's the mode we're probably going to use on this sample. Even though it's a tissue, this is a bit challenging tissue because it has a lot of empty space. And in order to image this, we will have to use the low vacuum mode. So yeah, it won't cut anyway, and it's not focused. Let's actually stop the run. Now I can hit stop button, it will stop right away. And the files that we collected are within these 3 folders, and I can load them to see. But I'm not really that much interested in these 3 ROIs, so let's actually do a little bit different. I go to the preview. I would like to get some of cells within the scripts. What I will do, I will navigate, let's say, to this script. Then I press preview. Yeah, so this is good script. But now I'll need to focus first. To focus, I'm using the search mode, which I designed to have a small width and small height of the area, but at the same time to have quite slow dwell time. This way I can get quite nice signal to noise, and it allows me to easy focus. We do stigmation and focusing on a certain area, but it's important to move the area from time to time to make sure that the image is not really we still focusing on the top of the block face, because while we're doing the focus, we actually burn a small hole, which means that our focal plane may be shifted into the tissue. As far as the focusing is done, we stop it, and then we can take an overview of the area. I switch now to the preview mode, and then I'm a little bit zoom out to see a little bit bigger context of the tissue. And when I'm happy with the magnification, I can take an overview. And let's go to run 1, check our capture settings, and press the capture button. Now we take an image of the area, and the idea is that we will do a few cuts, and after a few cuts we compare whether we have any changes or not. Let's make the cutting speed 0.2 a little bit slower than it was. Make cutting thickness 200, and let's do 10 cuts. So altogether I will be removing 2 micrometers from the tissue. Now it's fast forwarding through the this approach mode. It's done, and now we will do another capture and compare the results. If we reach the block face with the knife, then we'll see differences, and apparently now it looks that the images are different, and this way we can conclude that we are now at the cutting plane. The sample is not suitable for high vacuum, and because of that we have to use low vacuum for imaging. Let's switch off the beam, and let's turn on the low vacuum mode. First we can start with the lowest pressure possible, and when you first start it, you just make sure that tell the software that there are no any accessories installed. When you see here, when you see that the chamber pressure is going down and eventually it reaches the target 0.1 millibar pressure. Okay, let's wait a few more moments. Now we sort of reach the pressure, and then we can switch back to the GMS software. Let's start the view and focus. Oh, I forgot to turn on the pin. Let's go back to the XT interface and turn on the beam. So we do the focusing again. It might be that the focus in the high vac and the low vac may be slightly different. You navigate to the area where you see some nice structures. And actually already from here we can see that the sample is not stable. It's drifting somewhere. And most likely, in order to deal with this, we have to increase the pressure in the chamber. Let's try to make it 0.2 millibars. It's important that when you switch the pressure, you turn off the beam. Otherwise, you may an extra pressure may be injected into the chamber, and that may cause arcing between the detector and the sample, causing that preamplifier on the free view may get burned. Now you can see that while we're focusing, the sample is more stable, it doesn't drift anywhere, and we can have a little bit easier task to focus on the sample. We do focus, we do stigmation, and then repeat the focusing again. And when the focusing is finished, we can take the preview image to navigate towards the area of interest. In this case, we'd like to take the script. Let's have this view, this magnification for our overview. We can change the parameters for the overview. Now it's 1K by 1K, and then I hit capture to take a snapshot. So the snapshot is taken. Again, in this case, I'm interested in the central crypt, and then I can move the snapshot to run 1 workspace. Now it's in run 1, and then I can assign it to the survey mode as the survey image. For ROI, I can specify any parameters I want, like image size, the pixel size, pixel time. Let's see now, for example, pixel size to have 15 nanometers and dwell time 8 microseconds. And then we collect each frame. Then this ROI we can position the way we want. For now, I just quite randomly position it. And then in the data acquisition bar, we can define the step as well as where we want to save the data. Let's call it run 2. And when we're ready, we can press the capture button to start acquisition. First, we have a chance to see our area. And then if we need to adjust it a little bit, we can cancel at this moment, shift the ROI box wherever it needs to be placed, and then restart the run. Now Microtom is making a cut, and the imaging starts. Let's take first few images. Okay, so now we have 2 images, and then now we can check. Let's see, so I use the arrows on the keyboard to see the changes. Apparently the knife is cutting. It might be that somewhere in the middle it's still not completely cuts. So what we'll do, we just do a few more cuts, and then after that we retest the situation. So the cutting finished, at least, or it's continuing, but now we have a bit like 5 or 6 slices, and we can check how cutting is going. It goes pretty well. In all parts of the images, the tissue is cut, but it might be not really focused. At this moment, I would like to pause the run and then do the focusing. It's important that I hit the pause button when the imaging of the previous slice is going on. You shouldn't press it when the microtom is cutting, because if you stop it, if you pause the run while imaging is going, you can after that go to any locations for focusing like I'm doing now. And then when I resume the run, the 3 view will automatically jump back to my position. If you do this pause the run when the microtop cuts, then the first images that you collect, they will be at the wrong place. Alright, so I refocused and then I resume the run, and then it's continuous. So we can leave it for now. You can come and check how run goes from time to time or for the remote connection. And so far it looks good.
So we collected now 104 sections. Now we can pause the run and then wait until the next cut will be done. So now it's doing the cut. The cut is done, and now we can stop the run. So as a result, we collected 105 sections, and then we can process them later. Now I will close everything here. So I close this, the collected data sets. And then we need to switch off the beam. We're in the low vacuum mode. We go to the high vacuum mode, and then for now we switch the beam off. So I would like to remind again, whenever you change the pressure or the vacuum mode, remember to switch off the beam. On this system is very important, especially if you work in the low vacuum and you want to change the pressure, because the reason that it might be some extra pressure building up within the pipes and tubes in the system, and then we change it to another value, it can instantly boost quite significant pressure into the chamber, and then it may arcing between the diode and the stage when you're working with review. As a result of this, you may burn the preamplifier on the system, and the only way to deal around this is just to make sure that you turn off the beam, and then after that change the mode or change the pressure. Okay, so we finished with the run. Things seems to be working fine, and the next task will be to process the collected data sets.